Lesson 4.2. Our learning target is I can represent a linear equation in all forms. Our essential question today is how do you write an equation in slope-intercept form when you know 2 points on the line? So our first example says write an equation in slope-intercept form for the line that passes through 1, 3, and -2, -3. Notice I've got 3 formulas up here. I'm going to start with the slope formula because if we're given 2 points on a line, the first thing that we need to do is use them to find the slope of the line. So it's very important to label your ordered pairs. The first ordered pair has an x-coordinate and a y-coordinate, and I'll label it with 1s to represent the first ordered pair. The second ordered pair has an x and y coordinate, but gets the labels x2 and y2. Remember, your ordered pairs, the numbers are always in alphabetical order, so it's always x before y. Now, if I plug in my numbers in my slope formula, noticing that I have a subtraction between them, y2 is -3 minus y1 is +3. And then x2 is -2, x1 is 1. So this is my fraction to simplify. -3 minus 3 is -6. -2 minus 1 is -3. And I can divide these. -6 divided by -3 equals +2. So now I have my slope. So remember, my slope is the letter m. And now I can move on to my point slope form and plug in my values. So in point slope form, what I'm doing is substituting x1 and y1 and substituting my slope. So these 3 numbers I can replace. So y minus my y1 is 3 equals my slope, and then x minus x1 like that. And now all I need to do is solve this equation to get my final answer into slope-intercept form. So I'm using 3 different formulas for this process. I did the slope formula first, and then point slope form. And now I simplify using the distributive property. 2 times x is 2x, minus 2 times 1 is 2. So y minus 3 equals 2x minus 2. And then I'm trying to get the y by itself. So I add 3 on both sides. And my final answer is y equals 2x plus 1. So we took 2 points that were on the line, found the slope, wrote it in point slope, and then solved it. Example number 2, same process. So slope formula first, and then point slope. My first ordered pair, -3, 5 this time. And my second ordered pair, 1, -7. So in my slope formula, I have subtraction. y2 is -7 minus y1, 5. And then x2 is 1 minus x1, -3. -7 minus 5 is -12. And 1 minus -3, this turns into a plus. 1 plus 3 is 4. So -12 divided by 4 is -3. Point slope. Now I need x1, y1, and my slope to fill in. So y minus 5 equals the slope times x minus negative 3. This will turn into a plus, and I distribute. So y minus 5 equals negative 3x, and negative 3 times positive 3 is negative 9. And then I can add 5 on both sides. So y equals negative 3x minus 4. I guess I missed the first one. All right, so my last example, xy, first ordered pair, xy, second ordered pair. y2 minus y1, 13 minus 6, and then x2 minus x1, 4 minus negative 3. 13 minus 6 is 7, and this turns into a plus. So 7 divided by 7 is 1 for my slope. And then I can substitute x1, y1, and my slope is m. So y minus 6 equals 1, and then x minus negative 3. So this one turns into a plus. And distribute. 1 times x is 1x, plus 1 times 3 is 3. So y minus 6 equals 1x plus 3. Add 6 on both sides. So y equals 1x plus 9. So remember, we're starting out by finding the slope of the line, then plugging in a point slope, and solving it so that our final answer is in slope-intercept form. So we need y to be by itself.